that quiz that you took, or that was take-home quiz, right? And turned in. I graded them. I forgot to record them. So if you could send me a picture of your grade, just email it to me. Give me a picture of it. I'll record it and add 2 extra credit points to it. So just let me know, or just send it to me. Some of you have already done that. Great. And then you should have it recorded. And again, you should notice that your score is 2 points higher than it was the way you got on there. So, yeah, so if you find that one, email that to me. Like I said, just take a picture of it, send it to me. I messed up. It happens. Actually, I can't remember the last time I did that. Forgot to record them, but it happens. People make mistakes. It's fine. All right. Any questions at all before we talk some more about law of cosine stuff? Everything's going all right? All right. Well, let's look at this last bit on law of cosine stuff and give another formula for finding the area of a triangle. Remember, we had one that we've already talked about. Pardon me. One of the formulas that we had was that we can find the area of a triangle by doing 1/2 of the product of 2 sides and then the sine of the angle that's in between them. We've talked about that before. I can't remember when. It's been a couple of weeks at least. But the reason why that one works, let's say we had maybe your A is here, and your B is here, and your gamma is here. So let's say this is side vertex C there, A over on the right, and B up here. The reason why this works is remember that your formula for the area of a triangle is 1/2 base times height, right? Well, the way I drew this picture, what do you think I want to use as the base? B, right? So if I take this perpendicular down, this would be the height, right? We agree? If I do that perpendicular down, that would be your height. Well, notice that if you're given A and gamma, we can figure out the height. What trig function relates A, gamma, and H? Sine does, right? Sine of gamma would be H over A. If I solve for H, you would just get A sine of gamma there. So really, this formula we came up with before was just your same formula that you've known for a long time for area of a triangle, right? 1/2 base times height. We just have trig to help us figure out what the height is. Notice that requires 2 sides and an included angle. When we talk about Heron's formula here, we have, pardon me, 3 sides given to us rather than 2 sides and an included angle. Now, from what we talked about last time, we know that if we I'll have all 3 sides of the triangle, you could figure out one of the angles, and then you could use that area formula to do it. Absolutely. But there is another way to get at it where you don't actually have to calculate the area. Excuse me, the area. You don't have to calculate the angle to get the area. And this is what, again, known as Heron's formula. So the formula is you have the square root of this S that pops up. So it's the square root of this S times S minus A times S minus B times S minus C. I need to tell you what S is. We've talked about something that was represented by S before that has absolutely nothing to do with this one. Okay? The S in this case stands for what's referred to as the semi-perimeter. Remember, perimeter is add them all together. So semi-perimeter would be take half of it. So again, this is called the semi-perimeter. I'm not going to go through the proof because it's not worth the effort to get to this formula. But we said that we already had an area formula involving two sides and an included angle. And we can figure out an angle given all three sides using the law of cosines. So you can go through all of that mess and get to that point. I would not suggest doing that. I'm just like, you can't do that. I believe they do it in the book. If you really, really, really want to see the formula derived, you can go look at it in the book, or you can come talk to me in my office. I'm happy to go through it in my office. I just don't want to waste the class time on it. Especially since I'm guessing probably don't care. You might care, but I'm going to take, if I were betting, I would bet you probably don't care. And given all your reactions, I'm going to take a wild guess and say you really don't care. Okay, cool. All right. This is pretty straightforward to, pardon me. This is pretty straightforward to get at, to do it this way. So when you find that, that example up here, pardon me, goodness gracious. When we did this example, it gives you all three sides. So your semi-perimeter will be, I would calculate that first, figure out what that S value is. So you would just take up the three sides, add them together, divide by 2. So what do we get? 19? I did my arithmetic right. $11 plus 17 is 28, so plus 10 is a 38, divided by 2 gives me 19. So then your area is just square root of 19 times 19 minus 11. Yep, 8, good. And then 19 minus 17, so you get 2. And then 19 minus 10 will give you the 9. Goodness gracious, sorry. So what? You get 8 times 9 is 72 times 2 is 144. 80 minus whatever that turns out to be. I got a calculator laying here. I did my arithmetic right. Do you think I care if you simplify that? No, I do not care if you simplify that. Any question on that one at all? Oh, this is the straightforward application of the formula, right? Just plug the numbers in. Good old plug and chug. I mean, if you wanted to, you could verify that you get the same area by figuring out an angle and then using the other area formula that we have. If you wanted to check, make sure we're getting the same value. Both ways. I'm not saying you have to. I'm just saying if you wanted, as a practice, if you wanted to figure out one of the angles and then use the other area formula that we already have, you could absolutely do that. You should get the same answer. All right. So let's talk about how we would attack this one. First off, hardest question you're going to get all day. Is that a triangle? No. Okay. I lied. That's not the hardest question you're going to get all day. All right. So it's not a triangle, but I put this in this section or after that particular formula because I want you to use Heron's formula. Okay. Can I create triangles out of this? How can I create triangles?
You can make a line.
Yeah, sure. Make a line segment. Yeah, let's go. Say I go this way. You could also go across, right? I went up and down. You could go left, right as well. Why do you think I went up and down rather than left, right? What in the problem was given to me that made me not want to go left, right? Yeah, that 32 degrees over here, right? That value right there. I wanted to use that. All right, so now that you have two triangles and you want to use Heron's formula, I assume we want to use Heron's formula because I want to follow the 11th commandment. Thou shalt use the major theorem of the section to do all problems following that section. That's the 11th commandment. Okay. Okay. So I just introduced that formula. I probably want you to use that formula, right? Okay. All right. So now we have two triangles. I probably want to use that formula to figure out the area of those triangles. So what do you think we need to be able to, what we need to calculate first in order to be able to use Heron's formula? What do you think we want to calculate first? The new side, right? If I can get that third side, that length of this side here, then I can use it to find the area of that triangle and that triangle, and then do what with the two answers? Add them, because I got two pieces now, right? How would I find the length of that side? Say I call it C. How would I find the length of that side? Well, if I had a right triangle, I could use a trigonometric function, but I don't know that I have a right triangle, but we do have another formula we could use. Okay, good. So what equation would we get from the law of cosines here? You're right. I agree with you. Okay, and so what's the A and the B in this case? You're right. 12 and 11, good. Good. Yep. So remember, it's a squared plus b squared minus 2ab cosine of gamma in this case, as we're doing C. This one I would plop it in your calculator to get an approximation. What would you get for that value? 6.412, is that what you said? Okay. So what others got? Awesome. All right, so now that we have that value, let's say I have triangle 1 and triangle 2. What would your area of triangle 1 be? What would we have to calculate first? Yep, the S, good. So the S in this case will be okay. So that's the other triangle. But yeah, I agree with you for the other triangle. Nope, you're fine. I just labeled the other way around. So you said for this one it was 12 plus 11 plus the 6.412 over 2. And again, keep your digits in your calculator. All of your calculators should have a way to store a value one way or another. On the 84s, you can use any alpha character to store. On the TI-30s, there's like an XYZ button you can store in that as well. If you want to use it more than one time, I would use the storing functions of your calculator so you don't have to retype things. What did you get for this value? We did that one. Okay. The other one? Okay. That's fine. So you did 4 plus 7 plus 6.412 over here. That was like a times. You got 8 point, what was it again?
706.
Okay. And then using here, let's go ahead and finish off the first triangle so we're not flipping back and forth between them now that we have that one. Using Heron's formula, the area will be what? How do we use that value?
8.76.
Yep.
Times, yes, 4.
Yep.
Use 7, but
Yep. So it'll be 1.706 for that one. The last one will be a little bit different since we have the 6 point whatever number. Or I'll just write it as a subtraction problem since I'm getting lots of feedback for what the number is. Yeah. At that point, it's just a matter of plugging and chugging, right? Just getting it in there. Did anybody get a final number for that?
I got 12.663.
Okay. Seems reasonable. If this, for example, if this angle right here on the left-hand side were a right angle, what would the area be? If this were a right angle right here, what would the area be? For that, just this triangle. If this were a right angle, what would the area be? Didn't involve any trig at all. What would the area be if that's a right angle? And what would your base and your height be in this case? 4 and 7, right? Because I can just use the 4 and the 7 for the base and the height, so it would be 14, right? 28 divided by 2. So if that were a right angle, then it would be 14. If it's smaller or bigger than a right angle, it's going to shrink that triangle a little bit, right? So if it's not right, it'll be smaller than 14, which is what we got. Right? Just making sure. Again, this is just a does the answer make sense kind of thing, right? If you would have got 57, that answer doesn't make any sense, right? To give another, does it make any sense? Before we calculate the area of triangle 2, 32 degrees is close to what value that might be a special one that you know trig functions of? 30, right? Remember, the other formula for the area is 1/2 AB sine of gamma, right? 1/2 the product of the sides times the sine of the included angle. What's the sine of 30 degrees? What you should know, sine of 30 is? Sine of pi over 6 is 1/2, right? So if I do 1/2 times 1/2, would give you a quarter, times 12 would be 3, times 11 would be 33. Right? A half times a half is a quarter. Quarter times 12 is 3, times 11 is 33. When you do this answer for triangle 2, you should get something close to 33. If it's not close to 33, then somewhere along the lines we've made an error. It should be close to 33. Just by using the other formula and approximating that with 30 degrees. If you change the sign by 2 degrees, it shouldn't change much. So what did we get a semi-perimeter value for the second one? Was it? Sorry? 14.7. So when we do the other area, we'd have 14.7 times 2.7 times 3.7 times whatever 14.7 minus the 6.412 is. Hopefully you got something close to 33. I hope.
I got 26.9.
26.9, is that what you said?
Yeah.
I'm sorry, you got 34? Okay, that's a little bit closer. Yeah. Okay, we'll go with 34. Maybe there's something typed in wrong somewhere. Yeah. 34 even? 9.6? That's a much better number. Yeah. That would be what I would expect being closer to the 33. Yeah. Something a little bit closer. Arithmetic error aside or calculator issues aside, the process makes sense what we're doing. And then there's one more step we need to do. Add them, right? The very final answer, you want to add those two numbers together. So what do you get? 47.62-ish when you're done. Is the process okay? That's the important part here. I know there's a lot of typing, but is the process okay with what we did? And notice again, where it involved this particular problem, where it involved that law of cosines, was finding that last side. All right. Any questions about using the law of cosines to find the different pieces of the triangle? Because we spent a lot of time for solving triangles. Is that okay so far? Yeah. Well, let's see if we can do a couple of application problems. I already handed out the little worksheet thingy, so let's see what we can do. So we've got a balloonist, because apparently when Dr. Stickles made these problems up way back, when she taught trig the last time, she was happy to use hot air balloons going over things. Got a balloonist going over an island. You're given the angles of depression. You know how far the balloon actually is to each end of the island, and it wants to know how wide the island is from north to south. So all right, let's say we have a hot air balloon, and my island is down here. Got distances from north and south. Doesn't really matter which one's north and which one's south as long as we're consistent. It says the angle of depression to the north end is 32. So I'll make this my north end and this my south end. Just by the way, I've got my angles drawn here. It says the distance to the north end is 38.80. The distance to the south end is 28.25. The other thing we need to remember here is, remember, angle of depression is always off horizontal and down to where you're looking. That's angle of depression. So it always goes off the horizontal and down, right? Angle of elevation, angle of depression are always measured off the horizontal. Elevation is up, depression is down. So it says that the angle of depression to the north end is 32. So I know this angle is 32. This angle is 47. And it wants to know how wide the island is from north to south. How might we attack that? Say again? Good, exactly right. So to figure out what this angle is here, we notice that those three angles together make a straight line. Which means they have to add up to 180, right? So 180 minus 47 minus 32 gives you what? By the way, this exact picture, this has nothing to do with this problem, but this exact picture is the proof that your angles in a triangle have to add up to 180 degrees. I've got parallel lines, I've got cut by a transversal, so this angle is 47, that's 32. That's the proof that angles in a triangle have to add up to 180. Not that anybody cared, apparently, but that's okay. By the way, if you change your geometry, that's not necessarily true anymore. There are geometries in which the triangle that measures add up to less than 180. And there are geometries in which they add up to greater than 180. And before you think that's really, really weird, there's a geometry that definitely uses greater than 180 that you're familiar with, and that would be on a globe. Because it's rounded, it's not flat. Euclidean geometry requires things to be flat. So the angles wouldn't necessarily add up to 180 for triangles on a globe. Again, not that they necessarily care, but I'm full of useless information. Sometimes it just has to come out. All right, we're looking for width of the island. What would we use to figure out width of the island? Yeah, it'd be a lot of cosines, right? Because we have two sides and an included angle, don't we? So again, if we call this C on this side, what equation would you have?
C squared equals 220 or 2825 squared plus 3880 squared minus 2 times 2825 times 3880 times cosine of 1.
Right, this is just a straightforward application of the law of cosines. Once you find this angle at the top, it's the included angle. So we can just use the law of cosines to figure out your opposite side, that included angle. And what do you get?
5217.
5217, is that what you said? So what others got? Cool. Yeah. No, it was a pretty, like I said, that one was a pretty straightforward application of law of cosines, wasn't it? The only thing that you had to do that was before you actually applied it was figure out that third angle. All right, so let's look at the next one. This next one, they give you speeds of two airplanes. And then after a certain amount of time, how far apart the airplanes are. And then it wants to know what the angle is between their courses of flight. Well, since we're using either law of sines or law of cosines in these application problems, I'm guessing we probably want to set up a triangle. Okay. Whatever it happens to be. I don't really care if it's to scale or not. I just need to draw a triangle of some sort. All right. What pieces of information do we know about the triangle? And some speeds, right? So what can we figure out from the speeds? Okay, so how fast they're going and what the time is. So what can we figure out from that? How far they go, right? How would we figure out how far they go? What would we do? Good. Yeah, so the speed of the first plane's 140. We'd multiply it by 2.5 to figure out that side. Yeah? Was that 350? Say again? We'll multiply because we have miles per hour, and then we'll want to multiply by the hours to get rid of the hours. That's 350. I'm going to do that multiplication. Is that right? This will be 180 times 2.5. So that's 450. What other side do we know? Or do we know the other side, I should say? Yeah, it's 650 up here, isn't it? So they tell you that after that 2.5 hours, they're 650 miles apart. What's the problem asking for? Yeah, the angle across from the 650, right? Between their two courses. And what's the angle between those two lines here? I'll call it gamma. So I have all three sides. I just need to figure out what that angle is. So what equation would you use to figure out the angle? Okay. So we set up law of cosines. What would the equation look like?
350 plus 450. Oh, sorry, squared.
Okay.
Squared plus 450 minus 2 times 350 times 450. Cosine
Of the angle, and what does that need to equal?
Gamma squared.
The 650 squared?
Oh,
Yeah. Good. So the gamma is, the one thing I labeled with gamma is across from the 650. So remember, the angle and the side that are across from each other are on opposite sides of the equation, right? I know we typically write c squared equals a squared plus b squared minus 2ab cosine gamma, but the letters don't matter, right? Doesn't matter the letters. The important part is the side and the angle opposite that side are on opposite sides of the equation, right? So the 650 and the gamma are opposite each other. So the 650 squared and the cosine gamma are on opposite sides of the equation. I'm purposely trying to use the word opposite so it kind of sticks. Okay. All right, so then we solve for cosine of gamma. You'll need to subtract your squares over, divide by your -2 times stuff, and then do inverse cosine. Pardon me. So without me doing all the arithmetic, that's what a calculator is for, you should have inverse cosine of 650 squared minus 350 squared minus 450 squared all over -2 times 350 times 450. If you're a person that likes to type everything all in one line on your calculator at once, that's what you want to type in. If you like doing it a step at a time, please do. I just didn't feel like typing it in the calculator. Did you come up with a number? You got a domain error. Say again? It should be 108. Let me see what you typed in and see what the domain error was. I'm kind of curious. Oh. Yeah. Okay. So when you do it this way, make sure you have parentheses. That's why I was doing it. So what it did was it divided by -2, took that answer and multiplied rather than divided by everything. That's what it did. And in that case, you wouldn't get a domain error. Yeah. Others get 108-ish? Yeah. I got at least one nod. Thumbs up's always good. Got another nod. Yeah. Celebratory fireworks are always good. No? Tear a piece of paper, throw some confetti. Don't do that. That makes it a mess for housekeeping. Golf clap. I like the golf clap. All right. This okay? Are we good? Or do you want to do a couple more? Or are we good? I got one thumbs up. I got another thumbs up. Are we good? Feel like knocking off for the day? Yeah. Yes. Wonderful. That's what I like to hear. Okay. So we have an exam on Monday, right? So I'll bring a review sheet with me to class on Monday. Okay? Or Monday. Friday. Whatever damn day of the week it is. I'll bring a review sheet on Friday. We'll talk about what's on the exam. But the first thing we did right after the previous exam was finding those A, B, C, D things, right? On the quiz. That was the thing I emailed you about and forgot to record your grades, right? So that'd be the first thing. We also did inverse trig functions. Spent time on that. We did law of sines and we did law of cosines. So it should be too much of a surprise of what's on the exam. But I'll bring some review problems for Friday we can go through, make sure that we're on the same page. Just like the previous exam, there will be a short non-calculator part. It'll just involve doing some calculations of inverse trig functions of angles, or of values to get the angles. Okay. Making sure you know those basic ones. And then we'll have a calculator portion. Okay. So be set up like the first exam was. Alright? Okay. Well, have a good one. We'll see you on Friday.
Well, no,
Yep.
it was not.